All right, so this is example A. Now, the cherry flavored Lost Box snow cone is leaking from the paper cone at the rate of 2 cubic inches per minute. So the ice cream is leaking from the paper cone. So which means it leaks out, right? So we know the dV over dt, that's the negative. Why this one is a negative? Because it leaks out. So which means the volume of a cone is decreasing with respect to time. All right, now the paper cone top radius is 2 inches and height inches tall. When the depth of melted cherry mixture is 3 inches, how fast is the radius? Okay, so let me kind of like, whenever you're given a cone, we have to use kind of like a ratio of the radius and the height. So this is what it is. So the radius is a 2, so this is the radius. And this is a 5. Right? So this is the size of cone. And we know this one is a radius. We know this one is a height. Okay. Now, if you take a look at this, okay, so we can kind of like find out some relation between the radius and the height using a similarity, right? So big triangle over small triangle. Okay. So now let's find out some ratio. So the big triangle, 2 over r equal to big triangle, 5 over h. And then you can cross multiply, so which is 2h equals 5r. Okay, now if you go back to the problem, so when the depth of melted cherry mixture is 5 inches, which means when h is a 3, what is the radius? So which means we can plug in 3 to find out the radius. So let's plug in. So which is a 6 equal to 5r. So r is a 6 over 5. So which means when height is a 3, the radius is a 5 over 6. We can easily get the information. Okay, now, but since we already got that relation between the r and h, we're going to use it later. So now how fast the radius of a Rossby is changing. So what kind of formula we have to use? Because we are given a dV over dt, we have to use the volume of a cone, right? So volume of a cone, which is the V is 1/3 times pi r squared times height. Again, we need a dr over dt. Again, I don't want to deal with a two different variable. So I want to get rid of height. How? Because height is what? 5r over 2. So I'm going to plug in the 5r over 2 for height to get rid of it because I don't want to deal with a two different variable. So now here, so V is 1/3 pi times radius square, height 5r over 2. So which is what is it? So 5 pi over 6, isn't it pi of the r to the third part, right? So that's the volume. Okay, so now the question is how fast the radius is changing, dr over dt. So we can take the prime on each side with respect to time. So dv over dt equal to 5 pi carry down power, so 3r squared. So 3 can be canceled out, so over 2. So isn't it r squared times the dr over dt. Now dv over dt is a -2, so plug in. And we have a 5 pi over 2, and the radius, we already got that, which is a 6 over pi. So 6 over pi times quantity, second part times dr over dt. Now we have a -2, so 5 can be canceled out. Now 36, half of it, which is 18 pi, over, we have 5, right? Because a 5 squared 25, 5 can be canceled out, times the dr over dt. Now let's solve for dr over dt. So cross multiply, which is a -10 over 18 pi. So which is isn't it -5? Isn't it 9 pi? Now the rate is inch per minute. If you go back to the first sentence, it says inches per minute, right? So inch per minute. So inch per minute. Okay, now if you take a look at this, as the ice cream melted, the radius of the melted mixture It's getting smaller and smaller. So which means the radius is a what? The decreasing with respect to time. That's why this one is a negative. So we got the dr over dt. How fast the rosebud melt leaking onto the Nino Colpitts school clothes. So isn't it the same as the dv over dt? So which is the melted mixture, so leaks out from the cone. So that's the same as this value, right? So we know this one is 2 inch cubic per minute. We know this one is a positive because this one is a leaks out and this one is a what? Is observed on his clothes, right? So this one is a positive, this one is a negative. Now the C, so the Nino Colpitts is a small cylindrical cup with a 2-inch diameter beneath leaking the rosebud at this moment. How fast the height of a rosebud juice in a catching up cup changing. Okay, so this is a ice cream cup, right? It's coming out, and there is a cup underneath. So the question is what is a dH over dt? That's a question. Okay, so first of all, so the dV over dt, which is the melted rosebud, the volume of a dV over dt of the melted rosebud, that's the same as a what? The melted rosebud filled up in the cylinder, right? So these rate is the same. So here dV over dt is a negative because it leaks out, but at the same time, this one is a filled up, right? So we know the dV over dt. So in this case, the V is a what? The dV over dt is the cylinder, the volume of a melted rosebud. That's the positive 2. Okay, so this volume is the cone, right? And this volume is what? The cylinder. Because the amount of a melted rosebud anyway is the same. Okay, so that's a dV over dt, which is a 2. So we have to use the volume of a cylinder. So the cylinder, we know that is the area of a base, which is a pi r squared times height, right? Now let's find out the dV over dt. So first, d second, dH over dt, and plus second times dr over dt. Okay, sorry about that. I just don't have enough space. But if you take a look at this, dr over dt is a 0 because the radius stays the same. So this one is a gone. So everything is a 0. dV over dt plug in 2. The radius, it says the radius is a 2 inches diameter. So diameter is a 2. So radius is a 1. So pi times dH over dt. Now from there, we can get the dH over dt, which is a 2 over pi, and inch per minute. All right, the next one, the young boy is out at night, running away the street lamp, 6 feet per second. Okay, and street lamp is a 30 feet tall. The boy is a 5 tall. So this is a 5, and we know this one is a 30. And he running away. So in this case, we need several variables. So first of all, this one is the length of a shadow. So let me just length of a shadow. And I just want to set that, which is the distance between the lamp and the boy, equals d. Now, since he is running away from the lamp, we know the d, the distance between the lamp and the boy, gets increasing and increasing and increasing. So which means a d, why I use the letter d? Can I just use the x? I'm sorry about that. So dx over dt is actually positive. Okay, so which is a 6 feet per second because x is increasing. All right, so now how fast the shadow length is changing? So which means what is a ds over dt? That's the question. Okay, now the shadow problem, it is about the similarity, right? So don't plug in anything, okay, we have to use the variable. So here, like 5, 30, here is S and here is X. Now, big triangle, small triangle. So big triangle, base of a big triangle, which is a S plus X over base of a small triangle, S, equal to the height of big triangle, 30, over the height of a small triangle, which is a 5. Now, we know this one is isn't it 6 over 1? Now, cross multiply, which is a 6, S equal to S plus X. So, which is a 5S equal to the S. Right? So, how fast? Shadow changing. So, which means that they are looking for the ds over dt. We can use this formula. So, A, 5S equal to X. I want to take the prime with respect to time, which is a 5 times ds over dt equal to the dx over dt. Since they're looking for the ds over dt, we can just plug in. Dx over dt, that's a given 6. So ds over dt is a 6 and divide each side by 5, so 6 over 5. So this one is a feet per second. Okay, that's the A. Now B. Okay, how fast the tip of a shadow is moving. The tip of a shadow, you have to think about the S plus X, the total length, because the tip of a shadow. So you gotta think about the length between the lamp and the tip of a shadow, which means they're looking for the ds, the derivative of S plus X. Now this one is the addition of two functions, so ds over dt plus dx over dt. We already know that dx over dt is a 6. Dx over dt is a 6 over 5, so you can just plug in. So which is a 6 over 5 plus 6, which is sorry, I don't have a ruler. So which is a 36 over 5. This one is a feet per second. So which means a tip of shadow is moving, increasing at the rate of 36 over 5 feet per second.